Let's look at a few examples of solving oblique triangles. Our strategy overall is which tool can we use, and then we'll just use that tool first. The default is to want to use the easiest thing possible. If you have two angles, you just subtract to find the third angle. If we have a set of opposite parts, then we'll use the law of sines. Let's look at the situation that we're in here. Once again, we're playing the solve triangles game. I have to give you three pieces of information. I've given you A, side A is 12.3 centimeters, side B is 17.8 centimeters, and angle gamma is 105 degrees. So I've given you three pieces of information. That's the rule. At least one of them has to be a side. I can't solve a triangle with just three angles. That's two in the triangle. Well, we can't use the sum of the angles because I don't have two angles to find the third angle. And I also don't have a set of opposite parts. I have side A, but not angle alpha. I have side B, but not angle beta. I have angle gamma, but not side C. That leaves us with the law of cosines. So we don't have two angles. And we also don't have a set of opposite parts. So it's the law of cosines for us. We have to decide which part of the law of cosines we can use. And we only have one choice, which I guess means we technically don't have a choice. We know that gamma is 105 degrees, so that's the one that we're going to have to use, the one with gamma in it. So there's three parts to the law of cosines. We'll use the one with gamma. Because that's the angle that we have. So this is really what's deciding. So let's write down the law of cosines, the one with gamma. The one with gamma, see, gamma is opposite side C. So the gamma cosines is C squared is equal to A squared plus B squared minus 2AB times the cosine of gamma. I'm going to write down without plugging stuff in first to help us remember our law of cosines. So I'm going to plug in A, B, and gamma, and that will tell us what C is. So once we do this, we'll know what C is. A is 12.3, that gets squared, plus B, which is 17.8, gets squared, minus 2 times A, which is 12.3, times B, which is 17.8, times the cosine of 105 degrees. You may notice that I've written this in calculator syntax. I have the square root because it's the form is in C squared. So I just need to take the square root of both sides. Since I'm about to drop this onto my calculator, since we're just going to be dropping this on a calculator, I might as well just open up with the square root and some parentheses. So I'll do a square roots. Then I'll have 12.3 squared plus 17.8 squared minus 2 times 12.3 times 17.8 times the cosine of 105, close parentheses for the cosine, close parentheses for the square roots. Before I hit enter, I'm going to remember that I have a Cal 3 class and I have to switch out of radians back to degrees. Now we're ready to hit enter. And it looks like side C is 24.1 centimeters. I'm going to write 24.1 because the 12.3 and the 17.8 are using three significant figures. It makes sense to use three significant figures. So I'll make it match. Any questions? Notice I use a lot less parentheses because when I'm writing things down, I put a set of parentheses for every variable. But I observed that the 12.3 is just being squared and it's not negative, so I could just write 12.3 squared without the parentheses. It's not wrong to enter all the parentheses. It's just more typing. 12.3 squared plus 17.8 squared. Part of your facility with the calculator is knowing when you do need and don't need parentheses. Any questions on the first step? At this point, we have an abundance of information. I've got A, B, and sides A, B, and C, and I have angle gamma. More importantly, I have a set of opposite parts. I have gamma and C. Now we have a set of opposite parts. We have side C and angle gamma. We have a set of opposite parts. We don't have two angles yet, so we can't subtract to find the third angle. We have a set of opposite parts. We can use the law of sines. Moreover, we have to use the law of sines. We don't have enough information. Oh, wait, no, we could use the law of cosines again if we wanted to be fancy, but we should default to using the law of sines because it's simpler. It's just a ratio. So we got to choose A to find A or B first. We'll just go in alphabetical order. I'm going to find A first. Let's write down the law of sines that involves C and gamma. Law of sines states that the ratio of the sine of an angle to the side opposite that angle is constant in any triangle. So in particular, sine gamma over C equals sine alpha over A. Out of these four pieces of information, I know three of them, so let's plug those in. So I can say that the sine of 105 divided by 24.1 is equal to the sine of alpha divided by A, which is 12.3. Note that in this case, we are looking for an angle. That means we're going to have to use an inverse trig function. We know that when we use an inverse trig function, we're only going to be getting a reference angle. So that raises the question, am I going to have to put this reference angle in multiple quadrants? But we look at the given angle up here and it's 105 degrees. So the answer is no. We can't have two obtuse angles in one triangle. So we're not going to have to worry about it. In general, if we open up with the law of cosines, we're not going to have to worry about putting an angle in two quadrants. Although earlier we brought up that ambiguous case of the law of sines that could result in two triangles. I wonder what we'll do then. So we need to use a sine inverse. So alpha, I'm going to multiply by the 12.3 both sides. So sine alpha is 12.3 times 12. This is why I shouldn't have afternoon classes. Words, wrong order, come out of talking. So I'm going to multiply both sides by 12.3. So that's going to tell us that sine of alpha is 12.3 times the sine of 105 divided by 24.1. But we need to use a sine inverse because we're looking for an angle. So alpha is sine inverse of 12.3 times the sine of 105 divided by 24.1. I don't want to write it in calculator syntax because I'm about to put it into my calculator. Now notice that that 24.1 has been rounded off, but it's also the last thing that my calculator said. So at the ANS button down here at the bottom, second ANS, there it is a 24.1 button. So I'm going to type sine inverse of 12.3 times the sine of 105, close parentheses for the sine of 105, then divide by 24.1. I don't want to round that off. I'm just going to press second ANS and then close parentheses on the sine inverse. And it looks like alpha is 29.5 degrees. I use 3 significant figures for my 105-degree angle, so I'm going to use 3 significant figures here and call it a 29.5-degree angle. We saved ourselves some typing and some round off error by using the ANS key. To avoid rounding error. If we did not, like in this situation, if we do not have 24.1, then we might want to sine inverse 12.3 times the sine of 105, close parentheses, divided by 24.113516661 to get our 29.5. We don't need to use all of that, but why think too much about how much we need to use? Because if we just use 24.1, that might not be enough. Let's find out. Good, still 29.5. Now, we could use the law of cosines to find our third angle. We could use the law of sines to find our third angle. But if we have 2 angles, we just need to subtract to find the third angle. So at this point, now we have 2 angles. So if I want beta, is just 180 minus 105 minus 29.5. 45.5. And now I have all 6 parts of the triangle. The only time we really have a question about what to do is in our opener, that getting that 4th piece of information, that first found piece of information. Once you have an abundance of information, once you have 4 things about the triangle, you could probably get away with subtraction or the law of sines. And the law of sines is preferred because it's easier to use. You can use the law of cosines anytime you have like what we could think of as a full set, an A, a B, and a C. So A, B, and gamma, or A, B, and C, or A, beta, C, A, alpha, B, and I can't list them all. I will get way too confused. Anytime you have an alphabetical set of 3, that's a law of cosines problem. Anytime you have a set of opposing parts, then that's a law of sines problem. So at a certain point, you have choices. It's that first thing. How's everybody okay? So solving oblique triangle is the stuff that shows up in chapter 7. It opens with the law of sines, and then it goes into the law of cosines. I like to think in instead of thinking about it in parts, I like to do things all at once. And I want you to see that these are replacements for the stuff that we already know. Is everybody okay? Last thing, note that the law of cosines, if one of the angles is a 90-degree angle, the law of cosines becomes the Pythagorean theorem. If one of the angles that you're given is a 90-degree angle, the law of sines becomes sine of theta is opposite over hypotenuse. So if gamma is a 90-degree angle, then I just confused myself. Sorry. These are the 3 tools you have. I'm just going to cut that. I'm not going to edit it out of the video. I leave all my mistakes in the video. So I'm like, oh, 3 plus 5 is 15. I just leave that in. So what I want you to notice is that we still have 3 tools for solving oblique triangles. It's just a slight variation on solving right triangles. Instead of Pythagorean theorem, we got these law of cosines. And instead of using our trig ratios, we got the law of sines. All right, that's going to do it for today. I will see you all on tomorrow, everybody. No. I will see you all on Tuesday. Everybody have a good weekend, and thanks for playing.